Hey there. Hi. How you doing? I'm gonna slide to the middle of the screen here for a second. Welcome back. So let me do that a little bit. Just modify things while I'm moving to the middle of the screen because I think we're back on Instagram Live. I needed to update an app. I was away on vacation. A bunch of other things while I was gone. I guess apps updated and I couldn't do the Instagram thing with the old version. In fact, I'm gonna dig on my phone for just a minute. I'm not in a hurry tonight. I kind of have things reasonably under control for a change. So while we chat and get comfortable, I'm gonna dig into a lot of what I've done over the last couple days, maybe 10 days or so. And part of that is as I snoop on my phone, it says we've been on Instagram Live for about a minute, and we have a 4 minute time limit. That's the rumor I'm under. We're using a StreamOn as a desktop RMTP server or rebroadcaster. So I'm actually going to our oh yep, it says we're live right now. Cool. Yes, so I did it right. I did everything right using StreamOn as a free app for Windows. And if you are here, I'm going to disappear. If you're here and you're paying attention on Instagram, I'm going to disappear. This is actually happening on Twitch. So if you cannot, if you want to see more about what we've done with workshops, I posted something on Instagram this morning. I'm going to show that video in my live stream here. We're going to go through what happened, what should have happened, what went wrong, how did I adjust, and those kinds of things. But our Twitch handle is We Lift and Shift. You can go there and you can follow along there. If you don't use Twitch, we actually have another server. Streamlabs Charity hosts us on a website. I'm going to make sure that finds its way to our website and some resources because one thing I want to do is I realized this um, live streaming business is cool and everything, but there's no way to give you good solid resources when I'm done, and that was the goal, was to be able to share things and provide kind of the same thing I do with veterans, that the same thing that happens where I say, hey, look, hop online. You don't know how to do this stuff. Let me help you. And then, as we're done, they leave these workshops with this, not only just the confidence, but the access to some of the free websites and free resources that I share with them. And through the process of learning how to do this live streaming and Twitch mumbo jumbo, whatever happens here, apparently whatever happens on the stream stays on the stream, and I want to try to correct that. So soon you will be able to find some of these 3D models on our website. Soon you will be able to donate, and we will end up printing the 3D models for donors. That kind of thing it's going to happen. I just have to get around to coding. I'm such a slacker at coding. I'm an electrical engineer. That's I would like to make things go crash. That's like what I do. I'm an Army veteran first and an engineer second. And I see we've passed our 4 minute mark. Sorry if you disappear, Instagram, but go to Twitch. And on that note, I'm gonna come back over and do a little talking here. I think I've kind of got this camera thing lined up right. But yeah, so where was I? Oh yeah. So we're gonna spend, I don't know, I don't really have a time limit tonight. So half hour, I don't know. We'll see where we go. But I'm gonna talk through a workshop I hosted last week with about 50 people. I think it was a Zoom workshop with Wounded Warrior Project, who is such a fantastic supporter for me as a veteran, and the Lift and Shift Foundation as a sister nonprofit. They jump through hoops to support me and to give me the ability to give back to other veterans. So I tremendously appreciate everything they do, and they sometimes, get this bad image in the veteran community because they're this gigantic nonprofit, and we have a tendency to look at big things like that, like the evil empire. We see Disney Corp as one of those things. It's like, oh, they own everything, or some of those. I think Unilever is a big marketing company that owns everything. They own the advertising companies down to the manufacturing companies like Procter and Gamble and everything else. But I just I excuse me, I advocate for uh, a lot of veteran service organizations like Winter Warrior Project, because they 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 do a lot for veterans, and I get this added benefit of seeing what happens behind the scenes because I work with them as another nonprofit. So they they bust their tail, and they actually do good things for veterans. But now that I'm off my soapbox for a couple minutes, um, I'm going to go back to what we were doing last week on June 10th. That afternoon, we hosted about 50 veterans, 50 family members, 50 guests for a workshop where I introduced the idea of 3D printing. And believe it or not, most of us will understand this if you do any 3D printing or any designing. The process of building parts or a 3D model is half the battle. So that's where I start, because if you don't have a model to print, there's really no sense in firing up a 3D printer. Once you get a model, or your object, your product, your design, whatever is in here in your melon out into the real world, you you can send those files anywhere to be printed. You don't even have to have a 3D printer, and that's the goal. That's how I try to leave these 2-hour seminars with the impression that there's a free resource. Anybody can use it. Tinkercad. Excuse me. It's the entry level, I guess. The entry level AutoCAD. I'm gonna choke here. I don't know what's happened all of a sudden. But yeah. So Tinkercad. I'm just gonna pop it up. Is this it right here? I think that's it right there. Super. There it is. Right there. Right there. Yep. So Tinkercad is the entry level deal. You hop in here. You can make some super basic things. So, and being veterans, and being part of this community where we kind of have things that other people don't understand, and don't use, like dog tags or a P38 can opener. Not too many people carry those around in a corporate office that I saw. But there are things that we can do together that kind of like reinforce that bond, and make us all feel like we're not alone in a lot of other different ways. So I started with these keychains. I'm making these military themed keychains as a way to show veterans how to use the features in Tinkercad. I've moved on to these challenge coins, and this screen over there, right, dun, dun, right there. That is my browser right now. It's from June 10th. This is the model. This is what we worked on. It's right here. It is a challenge coin that we designed as a group, and we designed it as a way to introduce all of the features, like adding objects, grouping objects, resizing objects, aligning, placing, all the things that make Tinkercad uh, a fabrication platform, a design platform, a place where you can create. Um, that's how it happened. And these challenge coins are a great opportunity for me to show how those things happen. Because to be honest, when I first fired up Tinkercad, I didn't really get it. I was like, okay, so what's I got all these parts. How do I manipulate them? And once you see the group button, once you start joining objects or creating unions, or I forget what it's called. SolidWorks calls them a union, I think, or an intersection or something. I used to use SolidWorks a lot. I'm slowly migrating to Fusion, so bear with me for a minute. But I'm going to use all the wrong words. But yeah, so here in Tinkercad, it's grouping, and when you create a group, you kind of like fuse everything together. Once I figured that out myself, I realized, oh, okay, now I can make stuff. Now I can do this. And that's where I try to take this conversation over 2 hours with veterans, and this is the challenge coin that we designed together on June 10th after 2 hours of introducing, the features, dragging parts in, aligning them, resizing them, even coloring them, all of that stuff. And here I will lean up and say, here is the finished product right there. This is the challenge coin. You can see it in my hand, and this is probably the only time I'll break out a prop because I can already tell my screen is not going to cooperate with me. But here is the finished challenge coin in my hand. I went through a week of printing these out. After we're done with these veterans, I print them. I print the coin that we've designed, and I put it in their hands. I actually go to Wounded Warrior Project after I printed, the 30 or 40 or 50 or however many guests there were with us, so that they can see their model on screen, and then they can put their model in their hand and see, the differences in the 3D printing and things like that. So it's really cool. I love doing it. It's fairly popular. 50 people are hopping in on a Zoom just to see how this works. But behind the scenes, I don't have enough time to share how it goes from screen to real life. If you've done any 3D printing, you realize after we're done with Tinkercad, I export the file as an STL file. I throw it in a slicer. I use Cura, and a slicer basically turns this picture into a bunch of X and Y coordinates. It says, hey, 3D printer, you need to move your little 3D printer nozzle from here to there, and you need to squirt out this plastic after you heat it up to a certain temperature and all that other stuff. And that's how the 3D printer works. It creates these layers, or it creates this object by smushing together layers. It heats them up enough so that they are liquid, semi-liquid. They glass over. They soften to the point where they can fuse together. If anything about the chemistry behind the plastic, once it's at a certain state, the edges are no longer solid. They can kind of like mesh together. It's really fascinating behind the fabrication of styrofoam. Extruded polystyrene, styrofoam brand is really cool how it's made, because it's heated up much the same way as a 3D printer, and then it's put under pressure until the edges actually kind of disintegrate and fuse together into a solid object, just like 3D printing. So it's cool. It's just another nerd thing. I am an engineer. I do love kind of nerdy stuff. Just no math. I'm really not big on math. But yeah. So anyway, back to this print job. So I have 2 hours in this Zoom workshop. I don't have time to lay out a print run, go through all the temperature settings, make all my adjustments for my printer, and then print a test run to get this part hopefully all out nice and neat and fancy, and then print out batches and batches and batches. So I think on this print run I printed 10 batches of 5. That sounds about right. Yeah, 10 batches of 5. So I have an Ender Pro, an Ender 3 Pro. Yeah, that's the one. And I love it. I got a glass bed. I upgraded the glass bed. I did the upgraded motherboard. I'm looking into a laser attachment for the extruder head. Yeah, no, I'm like so fired up. I want to start cutting my own custom circuit boards. that will happen soon, and it will make its way to Twitch. I promise that if it happens. I'm big on that. We have a design team also that you know, we've been designing robots and things, and part of that process is building a custom motherboard, basically the brain for this robot. So it will be put to use. I will say that. And in the meantime, what I do is I use my 3D printer to, you know, print these things for these veterans as I get distracted by all the cool science nerdy stuff. And I don't have time to show them how to troubleshoot. And this week particularly, I realized this is a great opportunity for additional content, to be able to hop on a Twitch and do things that I haven't done before. To say, hey gang, if you want to follow along, here's what happened behind the scenes, because this is literally behind the scenes. I'm here by myself. I spent the week printing. Last week, I realized I had issues. I came to Twitch and said, hey, my first print run, it warped, it curled up, and I need to address it. I shared probably some parts. I got some parts here. You see the bottom of this? There's a star and it's missing. It's right here. Yeah, it wasn't staying flat on the bed, and I had I had a hypothesis. I had two different things that I thought possibly could be the problem, but these parts were not coming off. So last week I decided, hey, let's do this. Let's hop on Twitch and talk about this, because it's a real issue, and it's something I didn't get to share with anybody else. So hopefully this part benefits everyone who takes a peek and wants to know more about the 3D printing behind this model right here. So what was actually happening? I'm gonna ditch Tinkercad because well, Tinkercad's cool and everything, but it's very basic and very introductory. What I'm going to do is, here's the video I shared on Instagram this morning. I shared a screenshot last week when I started my first print run, and then I shared this morning because I'm going to come back and talk about it. So I'm going to switch views right now, just like this. I'm going to play this little clip of my Ender printing. You can see my fancy cool glass bed. I dig it. And if you look at the first layer of the first part printed, you can see that there's this odd little gap around the star, around the points of the star. Excuse me. And now that my camera raises up a little bit right there at the end, you can see the end result much clearer. But it looks like it's missing, or you know, something happened to it. It went away in that angle, and that's well, that's just evidence to show that the print was not optimal. So I'm gonna erase that. I'm gonna get rid of that view, and we're gonna hop into the very next view, where I'm gonna zoom in on the actual corners rather than try to hold up my little crazy star live here. You see in my hand, if you're catching my my overlay. This is not easy for you to see or you know, assess as a you know, as a diagnostic process. Even if I come back to like the full camera and try to show you, you can see that it's curled up tremendously here, but you can't get a good look at what's actually happened. So this was I think 3 layers, and then the printer had caught it and pulled it out. But it's much easier to get a closer look and a better look at what's happened with thankfully my Android phone and Google Photos. You can see that it's curling up. Even the very first layer. This is the first layer. You can see it's curling up, and I got some other issues here going on, but I'm going to ignore that for just a minute, because this was my first run. I just switched from a red PLA that I'll come back to talking about. and there were um, other changes that I made in the settings. So this is actually a really good view right here. You can see every point on the star already on the first layer start curling up. And I will say this, I don't use the setting straight out of the box for my ender because of the glass bed. Because of the glass bed, I had trouble getting things to stick the same way that I did to the standard bed. So I had to raise the temperature. I raised the temperature 4 degrees on the heated bed. The heated bed, for anybody who doesn't know about the 3D printing process, this like plate on the bottom that everything sticks to, it's usually heated to help the parts stick to it and help the parts from sliding around, because you're basically smushing down layer and layer and layer of new plastic over top of it to build up a solid object. And what happened here was my objects weren't sticking to the glass, so I had to raise the temperature slightly. So I went from 60 to 64 degrees, and I actually raised my extruder temperature to about 115 degrees. I think that's what I started with. And that worked out well for an earlier roll of PLA from the same brand. May I also add this is MakerBot standard PLA in a what do they call it, cool gray or something, I don't know, but yeah, so you can see this is a brand new roll. I opened it up to do this print run, and I had issues right off the bat. No problems. No really good print out of the entire thing. So if I don't know anything about 3D printing and I'm just looking at this, I'm thinking about heating and cooking and ovens and things. I've described this as a potato chip kind of thing. It looks like it's curled up like a potato chip, and already I'm thinking, so maybe it got too hot. Maybe the plastic got too hot. Maybe 215 degrees was too hot. So I wanted to change the temperature to see if that was a difference, but then I also realized that we're doing two things to this filament, this plastic PLA filament. We're heating it up and we're cooling it off so that it sticks together. And just like metal, plastic will expand and contract. So I wanted to say my first instinct as like a foodie was, maybe we're frying it, and in reality, it could be just the opposite. It could be that we're icing it, basically. We're cooling it off too fast. So I did not change settings initially. What I did was I hit the internet and Googled this MakerBot PLA, and that was indeed what MakerBot suggests, is that their PLA has issues with warping, basically, is what they call it, due to either overheating or overcooling. So I went back and checked my settings in my slicer software, the software that tells the printer, where to go and what to do based on the shape of your object. And I had the fan on quickly, soon, like right away. So what I did was I set the fan to turn off on the first layer, hoping that the first layer would stick and stay down. That did not necessarily solve my problem. You can see I went through several prints, and this is more than one layer. I think this was at the 2 or 3 layer point. I'm not sure where, but you can see where the stars actually that I was trying to hold up and show you had these issues. You can kind of see it there where it's curled up a bit right on the tip of both of these stars, and just turning down the cooling fan did not, or for the first layer, did not help me whatsoever. And here you can see, you can get a much better view. These parts look like potato chips being curled up, but down here you can see clearly the edges rolled up, and then when the printer head, the extruder, comes back by, it catches this and pulls it right out. So the very first thing I did, actually, and not even turning the fan off, while I was checking settings, I swapped in this red. If we go back here, you can kind of see right here. I mentioned earlier, there, right there in the center, that part peeling up was where my nozzle swapped over from red to gray. I had a red Overture PLA first, and I just wanted to see if I had if the problem was going to be with all my PLA, indicating that maybe, you know, this is a printer-wide problem that I need to adjust, or whether it was a material problem that I need to change in settings, just basically based on this roll of filament. So I went back to my red Overture PLA, and I had zero problems. I printed a whole batch, nothing, no problem. Everything came out exactly the way I wanted it. I could not have been happier with the Overture PLA based on the settings that I used. We'll leave that right there. The settings that I used stand like almost out of the box, and I've been using these settings for weeks now. The only real difference is, as I mentioned, I went away on vacation, and when I came back, my this PLA wasn't working, so I assume it was the environment conditions. That was basically the first test. The first troubleshooting step was, I went away on vacation. When I went away, it was spring. When I came back, it was summer. I had the air conditioner on, the ceiling fan on, and this was the confirmation that it was not an environment issue, that it was part of the filament issue. And the red like I said, the fact that I printed one run with this red Overture PLA, and then you know, multiple runs with this gray MakerBot PLA, confirmed that it was not an environment issue. It wasn't something I had have to say, hey, look at this. I'm gonna go change you know, all my settings in my printer for the summer because the air conditioner on changes, you know, how it interacts and the cooling. Excuse me. So then I had to go back and look at what else was happening here. That's when I really kind of took a look at these parts to see that, oh yeah, this is heating up, this is curling, this is overcooking. Not overcooking, but overcooling, basically, just this plastic. And I went through a process of this star only happens on the first 5 layers. So you can see it here after you get through a certain amount of plastic, or a certain amount of layers. It's tall enough so that this engraving part, this kind of impressed star and ring, it disappears and it's a solid object. So in fact, I can show you that right here. You can see where the infill starts on the top, and you stop printing these points and circles and shapes. But so the first 5 layers, I was using my settings. A layer was 0.2 millimeters, and these star engravings were 1 millimeter deep. So after the 5th layer, I started going all the way around and filling in the entire object. So for the first 5 layers, I turned off the fan manually to run a print through. And something else happened with that problem. That was working. It was solving my problem as far as the curling up. When I turned the fan off on my extruder, it stopped curling up. But then I noticed some clicking noises around the part that feeds the plastic in. And if anybody understands that, if you've done any 3D printing, you've probably experienced a bit of heat creep. Basically, what was happening was the fan was serving 2 purposes. It was not only cooling off the plastic and the parts, but to an extent, it was cooling off the big metal, like hot glue gun part that squeezes out the plastic. And as the heat kind of creeped up into that assembly, the plastic was starting to melt before it came out and sticking to the sides, and my extruder would not push the plastic out, and that's when you start hearing this loud clicking and popping noise. So turning the fan off solved one problem, but it created another problem. So I couldn't turn the fan off for all 5 layers in this star. So what I ended up doing was a series of test runs where I lowered my temperatures. I lowered both the glass bed temperature, 2 degrees, and this is where I ended up. I did this increment at a time. I lowered the glass bed ultimately 2 degrees from 65 to 63, or 64 to 63, 62, somewhere in there, but it changed by 2 degrees. In fact, it stayed at 65 for the first layer with the fan off, and then at the second through fifth layers, it dropped in 2 degrees, and the fan turned on to I think the final result was 30% of its max speed. But the other thing I did was I lowered the extrusion temperature. I lowered the temperature that melts the plastic, and that ended up cooling or not overheating my extruder, so the plastic was able to come out without jamming up. Basically, it's the same, it's similar to like a double feed in a magazine and a rifle. If you've ever served in the Army and the Marines, had to carry an M4, and you get that double feed, and you realize, oh no, I got too much in there, and it's just not going to work. It's kind of the same way. I compare 3D printers to very, very fancy, very, very expensive hot glue guns. And it's kind of the same thing. You can't jam 2 of those hot glue gun sticks into a hot glue gun and expect anything to come out. So that's the issues I had, and just these are the things that happen when when you're running these 3D prints and you set up a 3D printer. It's not very complicated, but sometimes the settings can be very tricky to fine tune, just like a carburetor in a car or something like that. You can easily be off by a degree, or too hot, too cold. We'll create some of these things, and it doesn't mean your 3D printer's crap. It doesn't mean you are doing something wrong. It just means that this roll of filament is different from the other roll of filament I was using. I'm not a fan of this MakerBot PLA, to be honest. This Overture brand I have here is much more accommodating to the environment, it seems. I've printed that everywhere from 200 to 215 degrees without really too many issues on some of these prints. And you can see this gray right here. This gray that I'm using is it's MakerBot standard PLA, and it's I won't even say that it's the brand. It could just be this roll. It could just be ooh, sorry, I mashed buttons. It's this they're made in batches, so it could be that one batch was made in when it's like 80% humidity out, or the other batch may be made when it's 90 degrees out, things like that. These manufacturing processes can change tiny details in even like one roll. So that is the end result of how I got to troubleshoot this, and ended up printing 50 of these challenge coins. And like I said, the opposite side of this works out much easier because it's all solid, it's all connected. But the bottom part, the part that prints first, the part that I created flat, had issues because it's actually it prints as 3 separate parts that kind of fuse together after it gets to be 1 millimeter tall. And those out of those 3 parts, they were shrinking, warping, so to the point that they don't fit together. And the problem with the shrinking was that, just like everything else that heats and cools, it expands and contracts. And having the temperatures fine-tuned to a point where the expansion and contraction is minimal, it is great. So like I explained earlier, as I'm kind of summarizing now, uh, we went through this process of turning off fans to slow down the cooling, which overheated the extruder and caused some heat creep, which then caused me to readjust the temperature settings based on this brand and this roll of PLA as opposed to the other PLA that I was using. And ultimately, I did get down to I still had some errors. I still was at like a 10% fail rate for the last couple runs, but in the end, it worked much better by not just turning off the fan or steadily increasing the fan until it got to a point where it was a solid object, but also changing the temperature settings, lowering the extruder and the bed temperature by 2 degrees. I bounced back and forth between 2 and 3 degrees on the extruder ultimately. I think I landed on 207, 208 as the temperature, and this is all Celsius, but I think that's where I landed for this roll and these runs. And the off the top of my head, the print bed started at 65 on the first layer and then came down to 63 for the rest of the print. And yeah, that worked the best for me for this specific print run. I think a lot of things people will find is these settings aren't perfect for every print and every size and shape. So it just reinforces the idea that when you're in Cura and you're looking at these, you can go through the process of after you prepare, you can switch modes to viewing every layer, so you can actually see all the individual layers. You could take a peek at each separate layer in Cura, and in the I forget what the tab is, what it's called, but there is where you can get a better assessment of, I've got all these different parts up until this layer, so maybe I should change my extruder temperature after layer X, or don't turn the fan on until layer Y, because this is clearly going to overcool these little parts right here, and they will shrink and curl, and that's it. That's basically all the feedback I can give from this week of printing these challenge coins. But I'm looking forward to doing this more, sharing some more behind the scenes parts. Just to wrap up, last week, June 10th, was my first trip back home, or my first return to work from a few weeks vacation. I noticed some environment changes. I went to go print, fired up my printer again, and couldn't get through a print run. So we had this awesome workshop with Wounded Warrior Project. We hopped online with about 50 people, 50 participants, and figured out how to use Tinkercad by designing this challenge coin. And it was a very cool process. I don't in these workshops get the chance to share the behind the scenes process, what happens when they design this in Tinkercad, and how it gets into their hands. But after the workshop, what people don't see is that I print dozens of these designs, and then I work with Wounded Warrior Project to put them in the mail, ship them out to every veteran, so they get to see these tangible physical objects in their hands that was on the screen in a Tinkercad workspace. And behind the scenes, nobody really got to see that until now. I'm starting to share a little bit of that. I printed like 50 of these coins, and in the process of adjusting my printer to a new PLA roll, and a new brand of PLA, a new or a fresh out of the bag, I think, not necessarily a new brand, but fresh out of a new bag with a brand new glass bed, and changing my environment basically from spring to summer, where the air conditioner was on, the ceiling fan was on, that kind of stuff. having to troubleshoot new settings, and that was it. That was basically it. A lot of airflow and a high temp on the extruder in the bed kind of created this perfect storm where things were over overheating and then overcooling way too fast. And ultimately, what I did was I turned down both the temperature and the fan speeds. It was a hit and miss project, and or hit or miss process, and it only applied to this specific role of PLA. Like I mentioned, I took this roll of MakerBot standard PLA out and swapped in this red Overture PLA on my glass bed. I had zero problems with it. Nothing with the settings I had out of the box from weeks ago. Springtime environment still applied to this. I probably will not change them in the future. But when I came back to my gray PLA here, you can see when I mash the button to zoom in, you can see the curling that happened. You can see right there the bit of red PLA from where I swapped in and out while I was running test runs. But you can see a big difference between the points here and here with the standard settings. So it was not necessarily the environment. It was not necessarily my ender. It was more this specific role of PLA, and I say this specific role because I had two of these roles, and I was printing this roll before I went on vacation with no problem. So for some reason, the roll I opened just happened to have an issue, and I would even go so far as to say that it wasn't an issue. It was just a minor variance that caused such a small curl. Very, very specific. It wasn't like these were all trashed and the whole thing was useless. You can see here on my hand, most of this printed very, very, very well. It was just when you get to these, basically start with 3 different parts and work up to the point where they join together into one coin. The star just was kind of fine for what I was doing. So that's the answer. That's how I'm going to leave it. I think next week I probably won't chat about the 3D printing end of it. I'll probably find something to design in Tinkercad. Or maybe I'll find something else to talk about in general. But yeah, this was a good 2 weeks. Laying out a hypothesis last week, jumping back here to share, hey, this is what really happened. Here's where my ideas were, and here's what was actually happening and what worked. Hope everybody enjoyed it, and I'm going to disappear and grab a snack, because that's what I do. I kind of like food. But in the meantime, okay, that's it. Yeah, I really am. I'm checked out. See you next week, unless I find some free time, which I already know I'm not going to. This week is bananas, so I will see you next week.